Hi everyone, today I'm going to be talking about nuclear energy and how it can be used to mitigate climate change. First, I will briefly discuss climate change and why we need to do something about it. Secondly, I will go into the basics of nuclear energy, how it works and how it mitigates climate change. I will then talk about the good and bad aspects of nuclear energy, followed by how the issues surrounding it can be solved. I will also discuss the importance of nuclear energy and its role in mitigation. Lastly, I will summarise what I've discussed. It has become clear that humans are influencing the climate system. Greenhouse gas emissions are at the highest level ever seen, the warming of the globe is undeniable, ice and snow are diminishing, and the sea level is rising. Consequences of climate change include decreased water quality and quantity, altered geographic range, abundance, interactions, and patterns of migration for different species, decreased and compromised crop yields, ocean acidification, and risk of extinctions. Controlling climate change and reducing its associated risks requires considerable reductions in greenhouse gas emissions. The extent of climate change-related damage will be significantly impacted by the emissions scenario, which is dependent on the mitigation strategies implemented. The scenario limiting warming to 2 degrees Celsius above pre-industrial levels involves phasing out fossil fuel use and a dramatic increase in electricity coming from low-carbon supplies, including nuclear and renewable energy. In terms of how nuclear power works to produce energy, it can be likened to a gas or coal-fired power station. The process of energy generation involves the production of steam that drives turbines which in turn produce electricity. It is how the steam is produced which differs between nuclear and other sources of power. In a nuclear reactor, uranium-235 isotopes are split, energy is released and the water is boiled. This process is clean, efficient, fully controlled, and the main wastes are the products from the fission process, which are kept in the ceramic cell for a period of time where they decay. Currently, 11% of the world's electricity is supplied by nuclear energy in 31 countries. Energy is produced using uranium and a simple splitting process, so it is clear that nuclear power avoids the carbon dioxide emissions produced by burning fossil fuels. Thus, energy generation using nuclear power can help to moderate climate change. Nuclear power can be thought of as a zero-cost mitigation option when considered in terms of dollars per tonne of carbon reduced. In fact, it has been concluded that nuclear power plants currently in operation avoid 600 megatons of carbon emissions per year, compared with generating the same amount of energy from coal-fired power plants. The obvious advantage of nuclear energy is that it produces less carbon dioxide emissions than fossil fuel-based energy. It is considered clean, all the waste produced are containable and manageable, and stations do not pollute the earth. When considering the entire life cycle of nuclear power plants, the greenhouse gas emissions per unit of electricity are near zero and at least 2 orders of magnitude lower than that of fossil fuel-based electricity generation. It is also a high-grade energy source. Burning a huge 120,000 tonnes of black coal produces the same amount of energy as only 1 tonne of uranium. Because very little fuel is required to generate energy, years of supply can be easily and cheaply stored. This is important as energy security is becoming an increasingly significant factor. It is reliable. The fuel is essentially unlimited, there is a lot of uranium in the earth, and technology will allow us to extract approximately 60 times more energy from it compared to current levels. Nuclear power reactors are cheap to operate and economically competitive if construction is timely, operation is at high capacity, and they are kept running over long periods of time. Additionally, nuclear power offers cost stability regardless of uncertainties in the fossil fuel market. Exploration, mining, processing and transportation of uranium in Australia significantly contributes to Indigenous and rural employment, and export income is similar to that of dairy exports. Despite popular belief, nuclear energy is safe. It is in fact considered the safest energy option and is heavily regulated in places like Australia. Importantly, nuclear energy also produces radioisotopes, which are crucial in health services where they are used in diagnostics and treatment of many cancers and for bone and PET scans. Plus, many smoke detectors require a small amount of americium originating from plutonium produced in nuclear reactors. Although nuclear energy has many upsides, there are some inherent disadvantages. These include safe disposal of radioactive waste, potential of major accidents, misuse of nuclear material by terrorists and to make weapons, and harm to the environment from mining uranium. These are what concern the public and make nuclear power a highly feared risk. Nuclear is even less popular than fossil fuels. Although perceived risks are often based on gut feelings and preferences, not facts, there have been serious accidents. The Chernobyl disaster killed 30 people, but it should be noted that the reactor responsible lacked fundamental engineering requirements needed for licensing in majority of the world. The waste produced are considered one of the most unpleasant wastes from current industries. They are hot, radioactive, and persist for up to 50 years. There is danger of ionizing radiation from uranium mining, transportation, and waste disposal. Additionally, mining effects can go far beyond the area disturbed in operation. Roads need to be made, material needs to be transported, and waste needs to be disposed. Mining can also cause controversy when in places of significance to Aboriginal people. Lastly, the reactors are cheap to operate but expensive to build, and currently nuclear power is more expensive than gas or coal-fired energy generation in the US. The main issues with nuclear energy are radioactive waste and the safety concerns associated with radiation. However, waste are produced in modest quantities and safe handling and storage is relatively simple. They just need to be cooled and shielded from exposure using things like water, steel, and concrete. Also, radioactivity decays and diminishes over time, and stored nuclear waste from civil activity has never caused harm, like radiation, or presented an environmental hazard. There have also been comprehensive studies into long-term disposal with deep geological repositories providing a potential solution. Considerable effort is dedicated to ensure workers and the public are not exposed to harmful levels of radiation, and the public standard is lower than the level normally experienced in nature. Reactors are structurally sound and reinforced with concrete. New generation reactors, deemed excellent in terms of reliability and safety, significantly reduce the likelihood of core meltdown and ensure minimum environmental impacts. The three major accidents need to be considered in 14,500 cumulative reactor years operating in 32 countries. Safety in design and engineering are highly prioritized, and it is important to note that the safety record is better for nuclear energy than any other major industrial technology. The 3 Mile accident in the 70s didn't cause any injuries and confirmed that conventional safety systems are effective. Even the recent triple accident caused by an unprecedented natural disaster in Fukushima was mainly contained on site. Lastly, procedures were put in place through the United Nations to discourage diversion and misuse of nuclear technologies or materials, and treaties were signed by many countries. It should be noted that no materials such as uranium from civil nuclear fuel cycles have ever been averted to make weapons. Nuclear power is being reframed and increasingly constructed by government advisors, industrial actors, scientists, and senior politicians as a solution to climate change. Ecologist James Lovelock has stated that nuclear is the only alternative to avoid climate-related disasters in this century because renewables alone won't be able to do it in time. Nuclear energy is being considered as a real green alternative, and all IPCC scenarios involve an increase in nuclear energy contribution from 2010 to 2100. The director of the UK Centre for Alternative Technologies summed up the situation by stating that the worst possible nuclear disasters are not as bad as the worst possible climate change disasters. Nuclear power is needed because even energy efficiency and renewable energy combined aren't enough to solve our climate crisis. Both expanding renewable energy and applying carbon capture and storage represent significant challenges and are more challenging than increasing nuclear energy. Nuclear power can be considered a superior alternative to other mitigation strategies. Apart from geothermal, renewable sources are only intermittent, dependent on local conditions, unable to deliver reliable baseload power, and often need non-renewable backup capacity. All renewable sources of energy have their downfalls, and nuclear power performs better than many in areas such as indirect fossil fuel use, non-renewable non-fossil fuel consumption, and amount of land required. Although not well known, nuclear power isn't the only producer of toxic waste. Waste from solar PV production include harmful toxic metals, including arsenic, which are indefinitely harmful. Nuclear power is an effective option to mitigate greenhouse gas emissions, and although public concern is considerable, opinions of nuclear energy are more favourable where nuclear power plants are operating as opposed to in countries that don't have a nuclear power program. This suggests that nuclear energy is effective and people can be convinced of its potential. There is only a small risk of public exposure to ionizing radiation, and this must be considered in a wider context which recognises the huge environmental benefits that nuclear power provides. The production and acceptance of more nuclear power plants will depend on new designs becoming more economically competitive and on the ability to re-establish confidence in the public regarding safety. The viability of nuclear power in the future depends on simultaneously meeting objectives in operating safety, economics, and waste disposal solutions. Thanks for listening.